When most people think of dinosaurs, they'll likely conjure up images of the stabbing teeth of the T-Rex or the cutting claws of a velociraptor. But what about the squishy bits of dinosaurs? To find out more, I've come to the University of Cambridge's Earth Science Department to speak with Dr. Alex Liu. Alex was co-author of a recent study detailing a fossilised dinosaur brain. I started by asking Alex precisely what he and his colleagues have described in the paper.
So we're describing a specimen of a dinosaur brain. And so usually dinosaur brains or skulls, you often find something called an endocast, which is a sedimentary infill of the cavity inside the brain case. Now, what we have is an endocast of a dinosaur similar to an iguanodon, so lived around 133 million years ago. And on the very outer surface of the endocast, what we find is mineralized preservation of some of the brain tissues. And that's very rare, and as far as we're aware, it is the first example of a terrestrial vertebrate in the fossil record where you can actually see brain tissue preserved.
So if it's so rare, how did you come across such a specimen?
So the specimen was found in 2004 by a fossil collector in Bexhill in Sussex. And so he actually makes a living out of collecting fossils. And he was walking along the foreshore there, along the beach, and noticed this pebble on the surface of the beach at low tide. And he picked it up and realized that it probably was related to dinosaur remains and bones that were found in the same area. And he kept hold of it, realized that it was probably part of an endocast of one of these dinosaurs, and showed it to various paleontologists in the next few years. And our role in this starts in around 2009 when my former PhD supervisor, Martin Brazier, was down in Bexhill and met the discoverer of the fossil, Jamie Hiscox, and saw this specimen and realized that there were some unusual markings on the surface of it. And he did think that it was possible that you had preserved brain tissue on the structure of the specimen. And so he asked if he could loan it and took it back to Oxford to conduct analyses on it.
So what you're saying is the minerals have actually replicated the brain. So what can you tell us about the dinosaur brain itself?
So what we see is a variety of crinkles and folded structures and little bundles of fibres almost on the surface of the specimen. What we think those are bundles of collagen. The outer surface of the brain in modern organisms is called the meninges, and this is a protective sheath almost, a tough membrane that protects the brain proper, which is inside those. And so these collagenous bundles, they are, we think, the meninges. But what's perhaps most compelling is that we also see evidence for these tubular structures running along the surface of the specimen, intertwined within the meninges tissues. And those are blood vessels. And they're still hollow little tubes, and they show beautiful little branches on them of fine capillaries. And they're running along the surface of this structure. And just beneath those, we also see evidence for a slightly differently folded layer of tissues, with lots of cavities and holes within that. And what we think is that that's very morphologically similar to parts of the brain cortex, so the actual brain itself.
How do this singular dinosaur brain compare to modern day reptile brains?
Most modern reptiles, they have brains which, if you were to take the cavity, the brain case, in which the brain is usually not preserved, but the brain is usually kept. The reptile brains usually take up about 50% of the volume of that brain case, and the rest, the surrounding tissues, are protective structures that fill in the rest of the space. And so if you were looking at the size of the brain case, you can't say that the animal's brain is of that same size. In birds, for example, which are the modern day relatives of dinosaurs, the brain fills much more of the space within the brain cavity. And so there's been questions in paleontology surrounding how much of the brain cavity the brain filled in dinosaurs, and potentially how intelligent those dinosaurs might have been. And so what we see in our specimen is that the meninges seem to be very thin. And so it doesn't seem like there's this very thick protective layer surrounding the brain tissue itself. It seems that actually the dinosaur brain might have filled considerably more of the space within the brain cavity than has previously been assumed. And that dinosaurs might actually be slightly more smarter than we give them credit for.
Not only does this suggest that dinosaurs may be more intelligent than we thought, it also provides the first evidence that we can find fossilised dinosaur brains, thus opening up new avenues of inquiry into these ancient creatures. That was Dr. Alex Liu of the University of Cambridge, and the study is reported as a special publication of the Geological Society of London.